In this problem, you're asked to solve the equation cosecant of 3x minus 1 is equal to 0, where x is between 0 and 2 pi radians. So the inequality right here, from 0 to 2 pi, you don't see degree symbols, implies that we're working in radians in this problem. So that's always nice to note when you start out. All right, so the first thing you should do with the equation is isolate the trig function. So let me write the original equation here. But first thing you should always do with these trig equations, if you can, if it's a linear equation, is isolate the trig function. And so I'm going to do that by adding 1 to both sides. Okay, so that was easy enough to isolate. Now, it's hard to think in terms of cosecant and secant. It just feels a bit awkward. So it's always nice to change it to its reciprocal function. Since cosecant is equal to 1 over sine. Cosecant is the reciprocal of sine. If cosecant of 3x is equal to 1, then sine, the reciprocal, and leave the inside alone, sine of 3x would be equal to the reciprocal of 1, which is 1. I mean, if you think of 1 as 1 over 1, let me get rid of this, looks like a fraction there. Yeah, if you think of 1 as 1 over 1 and flip it, okay, then sine is equal to 1 over 1 also. All right, so once you have the trig function by itself, then it's time to grab your unit circle. And I didn't paste 1 in because I knew we were going to have this value of 1. That's easy enough to just kind of picture. So remember that sine is the y coordinate when you're reading values on the unit circle. So sine is equal to 1 right here. Now I know we're working in radians, so pi over 2 radians is the value that we're looking for here. That's the angle that we need that gives us these coordinates 0, 1, so that the value of sine is 1. Now we finally address the 3x. So once you isolate the trig function and then use the value that you see in your equation to go and find the angle that you're looking for on the unit circle, then you take what's inside of the trig function, so in this case 3x, and set it equal to that angle that you found on the unit circle. So in this case pi over 2 radians. Now one other thing. Anytime you have more than just x inside of your trig function, so in this case 3x, or if you had x over 2, then you can start out by describing all solutions. I know that what I'm describing here is a little different than the way it's explained in my math lab, so this will give you an alternative. If you like the way that it's described in my math lab, and that's also the way it's described in the written solution in this PowerPoint, then go ahead and go with it. But for people where that's not really clicking, where you change the inequality to start out, this is an alternative. Okay, so while I was talking, I added the 2 pi in. The 2 pi in is 2 pi corresponds to a full rotation. So when you add 2 pi in, you're saying, all right, I have a solution at this position, and anytime I go a full rotation, there's another solution. Go a full rotation, there's another solution. And we could do that, until the end of time and keep generating more solutions. So this describes all the solutions. And again, you want to do this, describe all solutions whenever you have more than just x right here. All right, now we want to isolate x. So I'm going to divide by 3. Oops, divide by 3, divide by 3. And over here, since I've got this fraction in the numerator, I'm going to write that as 3 over 1. And then instead of dividing by 3 over 1, I'm going to write as multiplying by 1 over 3. Multiply by the reciprocal instead. And then I'm going to distribute that 1/3 to both parts here. Okay. Now when you're multiplying the fractions, you multiply the numerators and multiply the denominators. So pi over 2 times 1/3 is equal to pi times 1, so pi, over 2 times 3, so 6. So this is equal to pi times 1 over 2 times 3. Plus 2 pi n times 1/3. I'm going to write that as 2/3 pi n. Okay, so this describes all solutions. Now in the problem, let me get a new page. So if the problem just asked us to describe all solutions, then we'd be we'd be done. We could write this. What do we get? Pi over 6 plus 2 over 3 pi n, 2/3 pi n. This is an x. Okay. But we were asked for the solutions where x is between 0 and 2 pi radians. So we want those specific solutions. So we have to find the values that fit into that set. Pi over 6 is definitely going to be our first one. And so that's what we would have found if we had never even thought about adding 2 pi n. That's actually what you get in this equation when you let n equal 0. If n equals 0, then x is pi over 6 plus 2/3 pi n times 0, which would be 0. Okay, so pi over 6. There's our first solution. We want to see if there are any more solutions. So let's just increment that in. So say n equals 1. Then x is pi over 6 plus 2 pi over 3 times 1. We just want to see if, okay, if I add 2 pi over 3 times 1, does that still fit in this interval down here? Okay, but so to do this arithmetic, I need a common denominator, so I'm going to multiply top and bottom here times 2. So times 2 times 2 gives me pi over 6. Again, just multiply straight across, so that's 4 pi over 6, which is 5 pi over 6. Okay, so that's a little less than 1 pi, so that definitely fits in that. It's less than 2 pi, so it fits in this interval. So I'm going to add that to our solution set. And so as long as you're still generating solutions, you should go ahead and see if we can get another solution if, say, n equals 2. Keep incrementing the n until your solution gets too big. So pi over 6 plus 2 pi over 3 times 2, which I'll write as 2 over 1. Okay, but if I want to be able to combine those, again, I need a common denominator, so I'm going to multiply also by 2 on the top and bottom, so that this is pi over 6 plus, well, okay, 3 times 1 times 2 on the bottom, so that's 6, which is what I wanted. 2 pi times 2 would be 4 pi, times 2 again would be 8 pi. So we get 9 pi over 6, which reduces, if you divide the top and bottom by 3, it reduces to 3 pi over 2, which, okay, so that's 1.5 pi, so that's still less than 2 pi. So we want to add that to the solution set. And as long as we're still getting values less than 2 pi, I guess we should carry on and see if we can get away with n equal to 3. So let's see, x equals pi over 6 plus 2 pi over 3 times 3. Oops, 3, not 2. Okay, well that would cancel the 3's here. And so you're left with 2 pi plus pi over 6. That's going to be bigger than 2 pi. I mean, we got 2 pi and we're adding to it. So that's definitely bigger than 2 pi. It's too big. And so once you get a value that's too big, okay, that's not part of the solution set that we're looking for here, then it's time to close up our solution set here, and these are all the solutions to the original equation with x between 0 and 2 pi. You're done once you find a value. Once you increment your n's one at a time, and once it gets too big, then it's time to stop.